Hey there, fellow electronics enthusiasts. Today we're diving into the world of resistors, those little components that play a huge role in every circuit you'll ever build. Think of resistors as the traffic cops of the electronics world. They control the flow of electricity, making sure things don't get out of hand. Resistors come in different shapes and sizes, but one of the most important things to consider is their power rating, measured in watts. This tells you how much power a resistor can handle before it cries uncle and decides to give up the ghost. In this electrifying expose, we'll be comparing three common resistor power ratings: 1/2 watt, 1/4 watt, and 1/8 watt. We'll break down their differences, explore their strengths and weaknesses, and help you choose the right resistor for your next mind-blowing project. So buckle up and get ready for a wild ride through the exciting world of resistors. Let's talk power, baby. The wattage of a resistor tells you the maximum amount of electrical power it can handle before things get too hot to handle. Imagine a 1/4 watt resistor as a delicate teacup, while a 1/2 watt resistor is a sturdy coffee mug. You wouldn't pour boiling water into a teacup, right? Similarly, if you overload a resistor with too much power, it will overheat and might even go up in smoke. A 1/2 watt resistor can handle twice the power of a 1/4 watt resistor, and so on. So, when choosing a resistor, always make sure its power rating is higher than the maximum power it will encounter in your circuit. Size isn't everything, but it definitely matters in electronics. As you might expect, higher wattage resistors are generally larger than their lower wattage counterparts. This is because they need more surface area to dissipate heat effectively. Think of it like this: a small campfire can only handle so much wood before it gets out of control. But a bonfire, well, that's a different story. When building small, compact circuits, those tiny 1/8 watt resistors might be your best bet, but for high power applications, you'll need the brawn of a 1/2 watt or even a 1 watt resistor. Precision and stability are crucial in many electronic circuits. Resistors aren't perfect. Their resistance can vary slightly due to factors like temperature changes. Generally, 1/8 watt and 1/4 watt resistors are more common and readily available in a wider range of tolerances, often down to 1% or even 0.1%. This means their actual resistance is very close to their stated value. While 1/2 watt resistors can also be found in tight tolerances, they might not be as readily available in specialized or very high precision types. When it comes to durability and reliability, all three resistor types are generally quite robust. They can withstand a reasonable amount of shock, vibration, and environmental factors. However, like any electronic component, they have their limits. Extreme temperatures, excessive humidity, or mechanical stress can affect their performance and lifespan. In harsh environments, you might consider using specialized resistors designed for such conditions. These rugged resistors are like the off-road vehicles of the resistor world, built to handle the toughest challenges. So, when would you use each type of resistor? Here's a quick rundown. 1/8 watt resistors are perfect for low-power applications like signal processing, microcontrollers, and small-scale circuits. Think tiny sensors, wearable electronics, and those little blinking LEDs. 1/4 watt resistors are the workhorse of the electronics world, and they are a good all-around choice for a wide range of projects. From breadboard prototypes to hobbyist circuits, they've got you covered. When things start to heat up, 1/2 watt resistors are ready to handle the load. Power supplies, audio amplifiers, and motor controllers are just a few examples where you'll find them flexing their power handling muscles. There you have it, folks. We've explored the ins and outs of 1/2 watt, 1/4 watt, and 1/8 watt resistors. Remember, choosing the right resistor is like picking the right tool for the job. Consider the power requirements, physical size constraints, and desired precision for your project. And always double-check your calculations to avoid any unwanted smoke signals. Now go forth and create some electrifying projects. Happy building!